We are given the function q which equals f of t, and this equals 35 times of 0.92 raised to the power of t by 2. So basically q represents the amount of radioactive substance present after t years, and the unit of q is in grams. And let's answer the part A question, that is we have to determine the initial quantity. So to determine the initial quantity we have to put t equals 0 into this equation. So that is into the f of t equation. So therefore this becomes f of 0 equals 35 times of 0.92 raised to the power of, if we replace t by 0, it becomes 0 by 2. So 0 by 2 is 0. So basically this is 0.92 raised to the power of 0. Any number raised to the power of 0 equals 1. So therefore this equals 35 times of 1, and which equals 35. So this is the initial amount of radioactive substance present, and the unit of this is in grams. Let's do part B. Here we have to determine the annual decay rate. So to find the annual decay rate, I'm going to find the amount of radioactive substance after 1 year. So to determine that, we have to plug in t equal to 1 into this equation. So therefore, this becomes f of 1 equals 35 times of 0.92 raised to the power of, if we replace t by 1, it becomes 1 by 2. So we can plug this into the calculator. That is, this is exactly equivalent to 35 times of 0.92 raised to the power of 1 by 2. We can write down this as under the root of 0.92. So when you plug this into the calculator, we get approximately 33.5708, and this is in grams. So this is the amount of radioactive substance after 1 year. And to determine the annual decay rate, we can use the decay rate formula. That is annual decay rate. This equals amount present after 1 year minus amount in the beginning divided by the 1 year and times the 100%. That is, we put 100. So let's plug in these values. So this equals 33.5708 minus of amount in the beginning is 35 grams. So we put 35 over 1 times of 100. I'm sorry, this has to be over the initial quantity, which is 35 grams, and this should also be 35, because we are finding the annual decay rate. So the rate has to be with respect to the original or the initial quantity. So we plug this expression into the calculator. In fact, we can take the absolute value of this difference, and when we do that, we approximately get the rate as 4.08%. So this is the annual decay rate of the radioactive substance. Let's answer part C. So here we determine f of 8. So we can do this by plugging t equals 8 into this function. So we will get f of 8, and this equals 35 times of 0.92 raised to the power of t by 2. So we replace t by 8. So therefore this becomes 8 by 2, which in fact is 4. So I can write down this as 4. So this we can be plugged into the calculator, and when we do that, we approximately get as 25.07 grams. So basically this represents the amount of radioactive substance after 8 years. We now answer part D, that is we have to determine F inverse of Q. So here we are going to follow the method of finding the inverse of a function. So first let me write the function. This Q equals 35 times of 0.92 raised to the power of t by 2. So this is the function for q. And according to the method of finding the inverse, we first interchange the variables. That is, this q has to be interchanged to t, and this t over here, this has to be changed to q. So let's do that. So therefore, this becomes t equals 35 times of 0.92 raised to the power of q by 2. And from this equation, we have to solve for q. So that will be our next step. So to solve for q, first I'm going to divide both sides by 35. So when I do that, I get t over 35, and this equals 0.92 raised to the power of q by 2. The right side, we have exponential function or exponential term. So to solve for q, we have to take natural logarithm on both sides. So when I take a natural logarithm, I get natural logarithm of t over 35, and this equals natural logarithm of 0.92 raised to the power of q by 2. Now, when we use the power property of natural logarithm, this term q by 2 will come in front. So this can be rewritten as this equals q over 2 times of natural logarithm of 0.92. And on the left side, we have natural logarithm of t over 35. Now we divide both sides by this natural logarithm. So we'll be left with the q over 2 on the right side. So therefore, this becomes natural logarithm of t over 35 over natural logarithm of 0.92. And this equals q over 2. Now we multiply both sides by 2 so that we get the expression for q. So therefore, this becomes 2 times of, and this becomes q by 2 times of 2. These two will get cancelled, and finally we'll be having only q on the right side. So I'm just writing the right side as only q. So we got the expression for q in terms of t. Now let me rewrite this such that q is on the left side. So basically the expression for q equals 2 times of natural logarithm of t over 35 over natural logarithm of 0.92. And in fact, according to the method of finding the inverse, in the last step, we replace q by f inverse of q. So I'm going to replace this q by f inverse of q. So we find the function f inverse of q, which is 2 times of natural logarithm of t over 35 over natural logarithm of 0.92. Let's answer part E. So here we have to determine f inverse of it. So I'm going to copy this f inverse of q. So we have f inverse of q, and this equals 2 times of natural logarithm of t over 35 over natural logarithm of 0.92. So let's understand this f inverse of q. Basically, this represents the output, and this gives the time. And here, this t is the input, and this should be given in the amount, that is the amount of the radioactive substance in grams. So here the unit of the input is grams, and the unit of the output is years. So when we have to find f inverse of 8, basically it's asking the question, how long does it take for the radioactive substance to decay to 8 grams? So that is, we have to determine the time it takes for the radioactive substance to decay to 8 grams. So it means we take the input as t equals 8 grams, and we determine the time, that is q, how long years. So let's do that. I'm going to plug in t equal to 8 into this function, that is the inverse function. So we will have f inverse of 8, and this equals 2 times of natural logarithm of t over 35, that is 8 over 35, divided by natural logarithm of 0.92. We put this expression, that is this right side expression, into the calculator, and we approximately get 35.40 years. So we can see that f inverse of 8 equals 35.40 years. The unit is years. So it takes about 35.40 years for the radioactive substance to decay to 8 grams.